Here's an example of function operations. The operation we are required to do is this one here, I of x over g of x. First, I want you to notice something. This operation, I of x, just as well as g of x, they are not atomic operations. They have operation within. In here, this is a compound function because you have to solve this I on I of x, just as you have to do here g of x. So the proper or the easiest way to solve this out will be just to take this statement here on the numerator and this one in the denominator and solve them completely apart, just like independent problems. But actually, that's luckily I have done that in previous videos. The solution for g of x, which is this one here, you can see it complete in another video, just as the solution for I of x. They are both in other videos. I encourage you to watch them if you haven't, just to see how the whole picture of this solution. As well, I found in those videos the domain for g of g and the domain for I of x, and they are both here. Now, once we have all of it, we can actually proceed to solve this operation here. So I'm going to do that. Actually, in order to proceed quicker, I'm going to actually copy this statement here. Then I'm going to copy both g of g here, and I'm going to copy here I of x. I'm going to put it in here, and then okay, I'm going to proceed. Now I'm just going to write here the equal and the line here. Now notice something. I wrote here 4 steps on the left that you can use as a recommendation. They're just a very general guide, although I think they could be helpful. Let's see here. You already found the domain of the original function, which are this and this one here. Now we are actually in the second step here, which doing the operations here. But first, before going any further, because the next thing will be here just to do this sandwich rule and multiplying here this in order to solve this out. First, I have to tell you something, because this is a tricky problem in a way, because this is here a division here. So the division places just a restriction by itself, because what's in the denominator in here, this cannot be equal to 0. So g of g of x has to be different from 0. And here you could say, well, I'm just going to take this expression here. I'm just going to make sure it's not equal to 0. I'm going to say, oh, let's say 3 times x plus 5, it's different from 0. So x has to be different from -5 over 3. Well, you can see actually this -5 over 3 is already placed here in the restriction, in the domain from g of x, this restriction. You could say, well, that would be just it. But the thing is that in this operation of this division, you have to make sure that what's in here in the denominator, that is to say, in this case, g of x, it cannot be equal to 0. So if you think it as a whole, if this part here, this 2 times x plus 3, it's actually equal to 0, this as a whole, this would fall into a non-defined situation. You would have something divided over 0. And we have to skip that in every case here. So we have to respect fully this statement. That's why this is a tricky one, a tricky case. So I'm going to make sure to add as a restriction that this part cannot be equal to 0. I'm just going to do it in here. Be 2 times x plus 3 different from 0. So x has to be different from negative 3 over 2. Okay, so just let's keep that in mind. Let's keep this expression here. And here I'm going to continue just by doing this second step here, which is now doing the operations. In order to do them, here we have to use the super famous sandwich law, and we got it will be 6 times 1 minus x all times 3 times x plus 5 all over negative x minus 5 times 2 times x plus 3. And here maybe you could multiply these terms here in the numerator and denominator, but that will depend pretty much on the way your professor will ask you to solve this out. But just for the purposes of explaining this topic, this statement here will just work nicely here. So this statement here is actually the solution for I of x over g of x. That will be just the expression. In other words, we will be getting along with the second step now. Well, I'm actually going to sign the first and the second here. Now, in order to get the domain here, of this final expression, we should make sure that this statement here and this one here cannot be equal to 0. So this one in here, it's already placed in here. So that will be just it. Now I have to make sure that this one is not equal to 0. I'm going to do it in here. Negative x minus 5 has to be different from 0. So in other words, negative 5 has to be different from x. Now, luckily as well, this restriction is already placed in here. So we actually wouldn't have to add it to the final result. I just want you to notice something to you, because this could be tricky. This term places a restriction that is the one is placed in here. So it's actually already included, but I just want you to know, to mention something. Imagine you would have you would have some other term here. Imagine you would have as well here a 2 times x plus 3, another 2 times x plus 3 here, and it would come I don't know, from the product of other operations here. You would say, oh well, I could cancel out this one, and then by doing so, you would say you would cancel out this term here. Perhaps you wouldn't have included this restriction here, and that would have been a mistake here, because you have to make sure, since this part here, that any part of g of x would produce a 0. So that's why I did this operation, this restriction, first. That's why I did it first, because it could happen sometimes that these restrictions, for example, this term could be cancelled out in the final solution. If that would happen, perhaps you could have said, oh well, there's no point of including that restriction, but actually there is a point from a mathematical point of view. So actually the proper way to solve it would be just to first check from here if there some factor, some way that could convert this expression of g of x as a whole to a 0. So okay, I just wanted to mention that. Okay, actually now that we got we are actually going to get the domain of this expression. We actually just got it by this restriction, and this restriction here. Actually, the only thing left would be just to write all the restriction in one big answer here. And that's what I'm going to do here. I'm going to write in here. Domain will be all the real numbers except for, just going to write them in order. In ascendant order would be the negative 5, comma, negative 2, then negative 5 over 3, comma, negative 3 over 2, comma 1, and by doing so we are done. Just going to check this out.